All right, so today we're in conversation with Rivoningo Khosa, who is a research scientist at iThemba Labs. Sister, science. Has that always been the dream?
I don't know if it really has been always the dream. You know, when you're growing up and you're just outside and you get a little bit curious here and there, but at the time you're not really sure where it sort of fits into the scheme of things. But as you grow and you get exposed, then you realize that, you know, maybe science is where things are happening. You know, that's when it starts sort of looping into what it actually is. So I don't know if science was always the dream, but it may actually have been without me realizing.
Okay, so I think often when people look at scientists, they think that, you know, you guys are really, really clever. So has it always been smooth sailing for you?
Yes and no, because in high school it's different from when you get to university. So in high school I always sort of made it into the sort of top 5 in class, and that worked out well, you know. But the inquisitiveness, if that's the word, was always there. I was always keen on just learning more about things outside of the classroom, inside of the classroom. I was always interested, but not necessarily translating into being smart per se, but obviously as you grow, you sort of get exposed and you know more, you understand better. So it sort of translated further on. But the smart thing maybe got questioned along the way when at some point I did get academically excluded, and you know that sort of made me wonder whether I was as smart as I thought I was. You know, and you know that sort of hits you hard and you sort of realize that maybe you're not what you think you are. But obviously you pick yourself up and you keep moving.
All right, so I mean, you hit a speed bump, but here you are. So what exactly do you do at iThemba Labs as a research scientist?
So at iThemba Labs, I am part of the cosmogenic nuclides team. What that means is that we use geology and chemistry and physics, some math and stats along the way, to sort of answer questions on landscape evolution. What that entails is just going into the field for me as a geologist and collecting rock samples that then we bring back into the laboratory, and we sort of process through a series of mechanical and chemical processes that we sort of ask the rock some questions, essentially. So we break it down into its smallest components. So in our particular case, we are particularly interested in a mineral called quartz. When we are sampling, we obviously target rocks that have this mineral from geological knowledge, and then we take it into the lab and we sort of crush the rock sort of to liberate the mineral that we want. Then the samples go through a process of chemical etchers where we use hydrofluoric acid, hydrochloric acid, some concoctions of acids essentially that eat away at everything else besides the quartz. So quartz is a very robust mineral that sort of can withstand a lot of stuff. That's why we end up with quartz at the beach, because it sort of goes through every other thing, but it sort of survives at the very end. So quartz is a very robust mineral, so it stays the course essentially. And once we have the quartz, we take the quartz into what is called the ICP-OES to check the quality of the quartz, to check the quality of the processes that we take the samples through to make sure that the samples are ready. And in that, once the machines tell us that quartz is good enough, or if it's not, we take it back for the processes again. If it is, then that's great. What then that happens means the samples can now go through a process of column chromatography where we extract the isotopes that we want. In our particular case, we work with 10 beryllium and aluminium-26, which are then extracted from the quartz after it's digested, and they're packed into cathodes after they've been combusted to just liberate them into oxides, and then they get put into the accelerator and the spectrometer where they are analyzed.
So it sounds as if this is a place where the fundamental science and almost reality geology where they meet. But picking up from your story, it sounds as if you have the ability to go to fascinating places. So where is your research taking you?
Right now, one of our study sites is the Kruger National Park. You know, it's one thing just going into the Kruger and staying in your car and just looking at the animals and knowing there's a cheetah, a lion somewhere in the bushes, and maybe sometimes see some of these things. But getting out of the vehicle and walking away from it, you know, and just seeing the paws of the cat and still choosing to walk further away from it, it's a very challenging mental space to be in, because, you know, personally, I know I cannot outrun anything in the Kruger. I mean, even an elephant at its size runs faster than I do. So it's a very interesting and thrilling experience, I must say.
All right, so it's humbling.
Very, very humbling for the sake of science.
Yeah, face to face with Mother Nature. So just as we wrap up, you are clearly a rock star who's got the ability to listen and speak to rocks. But I'm sure that there are many young people out there who still think that science is stuff. It's not for them. Any final word that you would want to share?
Passion. I think that's the biggest word that comes to mind when I think about, future scientists, because it's not easy. I will not pretend that it is. I mean, I did fail along the way. It's not easy, but if you're passionate, if you stay the course, if you choose the science every day, I mean, experimental work, so that means it might not always work. But, just waking up and choosing the science and, just continue just scraping at it little by little is all I can say. Just stay the course and it sort of works itself out essentially.
Rivoningo, thank you for inviting us into your world where fundamental science, rocks, mathematics, statistics, chemistry, where it all comes together.
Thanks for having me.